Alright, so let's understand this problem now. So here we are given a list of intervals where each interval is represented by a start and an end time. And these intervals are already sorted by their start time and do not overlap with each other. Along with that, we are given one more interval called new interval, and our task is to insert this new interval into the list such that the final list remains sorted and there are no overlapping intervals, right? So if the new interval overlaps with any existing intervals, we must merge them. So let's maybe look at an example now. So we are given the intervals like this: 1, 2, 3, 4, 6, 7, 8, 10 and 12, 16. And the new interval is 5, 8. Now notice something important over here. The new interval 5, 8 overlaps with both 6, 7 and 8, 10. So all three of these intervals must be merged into a single interval 5, 10. And after inserting and merging, the final output becomes this, right? So that's the entire problem. Now let's see how we can solve this efficiently. So to solve this problem efficiently, we use a simple three-phase strategy, right? So in the phase 1, we add all the intervals that end before the new interval starts, right? Then in phase 2, we will merge all the intervals that overlap with this new interval. And finally in phase 3, we will add all the remaining intervals that come after the merged interval, right? So the key idea is that because the intervals are already sorted, we can process them in one single pass from left to the right in these three phases. So let's maybe start with the first phase, right? Our new interval is 5, 8, right? We look at the original intervals one by one. So first interval is 1, 2. Its end time is 2, which is less than the start time of the new interval, which is 5, right? So there is no overlap, and we directly add 1, 2 to the result array. So the result so far is this. Next interval is 3, 4. Now its end time 4 is less than 5, right? So again there is no overlap, and we add this interval as well directly into the result array. So the result so far is this: 1, 2 and 3, 4. Now at this point you will find that phase 1 is now completed, right? So now we move to the second phase, which is the merging of the overlaps. So the next interval in line is 6, 7. Now this interval overlaps with our new interval 5, 8 because 6 is less than 8, right? So we merge them, and the merged interval becomes 5, 8, right? Where start is minimum of 5 and 6, which is 5, and end will be the maximum of 8, 7, which is 8, right? So for now the merged interval is 5, 8, and the result so far becomes this. Now we check the next interval 8, 10. And this also overlaps with our merged interval because if you see 8 is already equal to 8, right? So we again merge them. And now the updated merged interval becomes 5, 10, right? Where end will be equal to maximum between 8 and 10, right? So now the merged interval is 5, 10, and the result so far becomes this. And now this also completes our merging phase, right? And now we move to the final phase, which is phase 3. And in this, if you see, the next interval is now 12, 16. And this interval does not overlap with 5, 10 because 12 is of course greater than 10, right? So what we do is we simply append it to the result array. And now our final result becomes this, right? So at this point, all the intervals have been processed, right? And after inserting the new interval and merging all overlaps, we are left with a clean list of sorted non-overlapping intervals, right? So the final output is this. And that's exactly what the problem asked us to return, right? Now maybe let's look at the code that implements this logic. So we start by defining a function called insert, which takes the list of intervals and the new interval as an input. Then we initialize an empty list called result to store the final answer. Then we create a pointer I to iterate through the intervals, right? And now we add all the intervals that end before the new interval starts, right? And these intervals cannot overlap, so we directly append them to the result. Now after this, next we handle the overlapping intervals. As long as the current interval overlaps with the new interval, we keep expanding the new interval by updating its start and end, right? So we take the maximum end time of the two intervals as the end of the final merged interval, right? Now once all overlaps are merged, we append the final merged interval to the result list. And finally, we append all the remaining intervals that come after the merged interval. And we return the result list which contains the correctly inserted and merged intervals. So that's the entire solution. Now let's talk about its complexity. So this solution, if you see, runs in order of n time, right? Why? Because we scan the list of intervals only once, right? So the time complexity over here will be order of n, and the space complexity will also be order of n because we store the result in a new list, right? And that's the only extra space that we are consuming. So this is the optimal solution, a clean three-phase strategy with a single pass traversal, right? So that's it for this particular problem, and now I will see you in the next one. Happy coding.